In this video, we'll explore the key concept of Java, along with the major or prominent enhancements that were introduced in Java SE11. We'll first discuss how Java has evolved over the years. Java basically started with the version Java 1, but most of the applications today are written using Java 6 or later versions. Java 6 was the last version released by Sun Microsystems, after which Oracle procured Sun Microsystems and released their own version titled Java 7 in 2011. The version, released post-Sun Microsystems, contained scripting API. Oracle also added the capability of bytecodes for dynamic language while making certain language changes, but it was more or less similar to Java 6. Java 8 was released with certain innovations and function-oriented programming powered by lambdas, and streams was implemented. Various other upgrades were made in date and time APIs, concurrency APIs, along with a few other APIs. Java 8 brought in major changes when compared with Java 7. With the release of Java 9, we get the capability of modules, and a utility called JShell was introduced. Java 10 made further improvisations on Java 9, and in this course, we'll be focusing on Java 11 LTS, which was introduced with certain improvisations in the stream class, along with the improvised lambda expressions for local variables. In Java 11 LTS, various other libraries were depreciated, and new functionalities were added in different libraries. And the latest Java version, which was introduced or released earlier this year, is Java 12. Now let's explore the basic architecture of JVM, or Java Virtual Machine, using the sample illustration figure. As illustrated in the sample figure, JVM is divided into three main subsystems that include class loader, runtime data area, and execution engine. The class loader comes with its own subsystem, and it essentially contains bootstrap class loader, extension class loader, and application class loader. Whenever a class is loaded, it will pass through a process of linking, which will verify the bytecode, prepare the bytecode, and resolve it. Once it's been resolved, it will be initialized, or, in other words, it'll be loaded and ready to create instances. The class loader is responsible for loading the class, passing it through the verification process, and making it available in runtime. The runtime data area generally contains various components depending on what needs to be stored. For example, it can contain a method area, which stores references of the methods, and a heap area, which stores objects. Apart from these, it can also contain a stack area to manage local variables. At a lower level, it can contain PC registers, which will communicate with native storages. Now, the execution engine is responsible for running the bytecodes, and it contains an interpreter, which comes with just-in-time compiler. This compiler not only optimizes and executes the codes, but it also profiles and performs garbage collection. The fourth element is a native method inference called JNI, which helps us interact with the lower-level systems. All the native method inferences are presented in the native method library, which can be observed at the bottom right of the sample figure. The runtime data area will communicate with the execution engine and call the native method inference directly. Having explored the basic architecture of JVM, the next topic we'll discuss involves the major enhancements that are introduced in JVM with Java 11. Firstly, we no longer need to install JRE. In other words, we can execute codes without compiling it using Java C. Not only that, we can now generate our own JRE. The third enhancement is based around the security level. Java 11 now supports TSL 1.3 version of transport level security. With Java 11, we also get two new garbage collectors, and they are ZGC and Epsilon. ZGC, or Z Garbage Collector, is a scalable, low-latency garbage collector, and it can perform all expensive work concurrently without stopping the execution of application threads for more than 10 milliseconds. Epsilon, on the other hand, is an experimental garbage collector, and it's also known as a no-op garbage collector. It doesn't have a memory reclamation mechanism, and the application needs to perform manual garbage collection. The fifth enhancement is one of the major JVM enhancements introduced with Java 11 from the perspective of class management. And this enhancement is the introduction of application class data sharing, which enables various applications to share data. Finally, in order to help simplify managing and understanding various elements of Java, an REPL tool called JShell Tool was introduced with Java 11. So these are some of the prominent major JVM enhancements introduced with Java 11. Now, apart from bringing about enhancements in Java, a few important truncated APIs were also introduced. For example, we now get a truncated API for bind, which is responsible for binding XML to Java objects. We get a truncated API for web services, which truncates class and inferences present in the web services library. We also get truncated APIs for activation, transaction management, and Cobra that provide the essential capabilities of implementing lower-level distributed computing. The next set of enhancements that we'll explore is based around the language. We'll briefly explore the language enhancements in Java 11 and their impact on applications. With Java 11, when we're writing applications, we can now run .java files directly. We'll no longer need to compile it. We can improvise the expressions for Lambda parameters by using the enhanced local variable syntax, specifically the var variable. Previously, there were less languages that we could use for shell scripting, but with Java 11, we now get shell scripting capability for Unix and Linux platforms with the use of shebang files. And Flight Recorder was also introduced as an open source in Java 11. Now let's explore the enhancements that were made to the string class with the introduction of Java 11. In order to help manipulate strings better, Java 11 introduced a few additional methods. The first such method is repeat. We can call this method to repeat existing strings for any number of times that we may require. The second one is blank. We can use this method to determine whether a given string is blank or empty. The third one is strip leading and strip trailing. These methods are alternate versions of trim. We can use strip leading to remove unwanted white spaces from leading strings or the beginning of the strings. We can use strip trailing to remove white spaces at the end of the strings. The fourth method is strip. We can use this method to remove white spaces from both sides, leading as well as trailing. And the final method is lines. We can use this method to manipulate lines directly instead of writing sophisticated program to identify the new line characters and integrate them as lines.